Hi guys, this is the video for 7.1, and so this section is just an introduction to what we're going to call differential equations. And so basically what a differential equation is it involves a derivative and the independent variable, and it can also have the dependent variable as well. So typically it's going to be something like dy dx, which is the derivative of y with respect to x. And then it'll be some function, mostly today we're going to have in terms of x, but we could see it in terms of x or y. So this is an example of a differential function. It involves a derivative, the independent variable, the dependent variable. It doesn't have to have both x and y. It could have just x or just y. But it's basically a derivative and the original variable, okay? Okay, so all we're going to be doing today is we're going to be finding some solutions to differential equations, and we're also going to be verifying solutions. So they are asking us to verify that y equals x to the fourth minus 5x plus 1 is a solution to this differential equation. Again, this is a differential equation because it involves the derivative and the independent variable, okay? So it involves the second derivative, so I do need to find that. So I'm going to find the first derivative here first. So we've got 4x cubed minus 5 is our first derivative. Second derivative then would be 12x squared minus 0, okay? So basically we're verifying that this solution is an equation. So when y equals this, here's my first derivative, here's my second derivative. So I can substitute my second derivative in here. So we have y double prime minus 12x squared. We're checking to see, does this equal 0 when I substitute this in for y double prime? Because this is completely based off of this being a solution. If it's not a solution, then this will not be true. So I'm going to go ahead and substitute that in, 12x squared minus 12x squared, and we're asking ourselves, does that actually equal 0? Yes, it does. So that means this is a solution. We just verified that by substituting in something based on this y into this differential equation. Okay, now we are going to look at finding solutions. Okay, so general solutions, I'm actually going to start with this. I'm gonna just put a little note here, okay? So the general solution to a differential equation, okay, it consists of all the antiderivatives of our differential equation. So the general solution consists of all the antiderivatives of the differential equation. Okay. And when they say all, remember there's a family of antiderivatives. We indicate that with the plus c, right? Because c could be anything. Now what this part is saying is suppose we find this general solution. If we're given an initial condition, then we can find a particular solution we can solve for that specific c value. So let's think about what this means. This is saying the derivative is 6x squared plus 5. So what we're trying to find is what is the original function here. What is a solution to this equation? So here is how we find that. We're going to find the antiderivative. So basically what I'm doing, you guys, is I am taking, yeah, let's do it like this. Give a little space. Okay, so what I'm doing is this is an equation. I'm going to do the same thing to both sides. I'm going to integrate both sides with respect to x. Integrate both sides with respect to x. Okay, so the dx's cancel. The integral and derivative also cancel, right? Integration and deriving are inverses of each other. And we're left with just y. So now we know how to evaluate this, right? What is the antiderivative of 6x squared plus 5? So we add 1 to the exponent and then divide 6 by 3 and get 2. And then this is going to be 5x. And then I have to include the plus c. So the plus c is what gives us the all, right? Okay, so this is a family of antiderivatives. It's a family of possible solutions to this original differential equation. Now they're asking me to find a particular solution with this initial condition. So now I'm given an x and a y to plug in here, and I can solve for c. So y is 10, x is 1, and we are solving for c. So let's see, we've got 10 equals 1 cubed is 1 times 2 is 2. So this is 7. If I subtract 7 from both sides, I get 3ac. So then my solution is still this antiderivative, but now I know the specific c that goes with this initial condition. So we've got 2x cubed plus 5x plus 3 is that particular solution with that initial condition. All right, we've got one more like that, where we are asked to find the general solution. Okay, so again, I am just basically going to integrate both sides to find the antiderivative and find a solution y equals. So if I take the integral of both sides, I'm going to be left with y equals the integral of e to the x plus 4 sine 2x. Okay, now here is, we can take the antiderivative of e to the x pretty easily, right? We can also pull out that 4. Now, sine of 2x, we'll hopefully get better at these ones, but this is one where I typically would have used u substitution. We can still do that. Let u equal 2x. So then du is 2 dx, or 1/2 du equals dx. So then we have y equals e to the x. We already, antiderivative of the x is itself, plus 4. We can pull out that 1/2 sine of u du. Okay. Antiderivative of sine is negative cosine. So we have e to the x. 4 times 1/2 is 2 times negative cosine of u. Now we're going to plug in our 2x back in for u. So we have y equals e to the x minus 2 cosine. Instead of u, we put the 2x back in there. Okay, and then plus c is always what we need when we're asked for the general solution. Okay, now we are asked to find a particular solution given this initial condition. So we're going to solve for c. Sorry, this c kind of looks like an e. All right, so we're going to substitute in 4 for y and 0 for x. Okay, e to the 0 is 1. Cosine of 2 times 0 is cosine of 0, which is also 1. So we have 1 minus 2, which is negative 1. So 5 is equal to c. So my particular solution is e to the x minus 2 cosine of 2x, and then plus 5. So that is the particular solution that goes with that initial condition. So really not a lot new here, you guys. Just kind of that verbiage differential equation, and recognizing it's just an equation that involves a derivative and could be the independent and or dependent variables. We're not always going to be able to nicely find the antiderivative, so we're going to look at some other strategies later in the chapter. But for now, we're building on something you already know. Thanks for watching.